Hello students. Now after completing the three important steps as far as absorption, then spontaneous emission, then stimulated emission, right? And important term is population inversion. Okay, in this we did mention that you need to expect the equilibrium condition can't be maintained, because in equilibrium condition what should happen? N1 is greater than N2. But to get this proportional inversion, what we said, N2 was greater than N1, and this was possible only when the temperature was negative. So proportional inversion was also, we named it as negative temperature state. Correct? So manage somehow by which the number of atoms in the energy level E2 is more than the energy level E1, that is N1. So now where you get this lasing action, okay, that medium you need to define. So today's lecture we will define what do you mean by active medium and what do you mean by metastable state, because these are the very important terms for the lasing action. Right? So first we'll define active medium. So basically we are very much aware that suppose you have these two states, ground state, okay, we'll call it as E1 and this is my E2. So you are very well aware that this keeps on happening all the while, absorption, emission, and so on. But for lasing we need stimulated emission. So we have to give energy to the electrons by which we get the light over here. That's what we have understood in this case. So now atoms are basically characterized by what? Large number of energy levels. But all types of atoms are not suitable for laser operation. Correct? So in a medium consisting of different species of atoms, only a small fraction, every atom will not be able to do that, a small fraction of atoms are suitable for the stimulated emission and obviously the laser action. So those atoms which cause our basic definition, light amplification. Correct? So those atoms which cause light amplification will be called as active centers, and the rest of the medium will act as a host. I'll say rest of the medium will act as host and it will support the active center. Fine. So the medium hosting the active center is called an active medium. Correct? So we'll again name it the medium hosting active centers is called an active medium. That's what we wanted to define. So an active medium is basically a medium which when excited reaches the state of population inversion, means this, and causes light amplification. Correct? So the active medium can be either a solid, liquid or a gas. That's why we have all three types of lasers. Fine. So what we understood over here, that to get every atom will not be able to do the emission. Correct? So what should happen basically? Only a small fraction of atoms are suitable for the stimulated emission and the laser action. So those atoms which cause the light amplification will be called as active active centers, and the rest of the medium will act as a host. Then what we said, but what is their job basically? To support the active centers. So the medium having the active centers is called as active medium, and the job is what? The job is to expect the population inversion and causes the light amplification, and the medium can be either a solid, a liquid, or a gas. Right? Afterwards we'll move to the next definition. Again, it is equally important, called as metastable state. Okay, now what happens in this metastable state? In this metastable state, an atom can be excited to a higher level by supplying energy to it. So the excited states have very short lifetimes and they release their excess energy immediately. Immediately means what? In a matter of what? Nanoseconds. The nanosecond time is required for the spontaneous emission. So atoms do not stay at such excited state long enough to be stimulated to emit their energy. So the pumping agent continuously raises the atoms to the excited level. Many rapidly undergo spontaneous transitions. So population inversion cannot be possible or cannot be established. So to do so, to get the population inversion, what do you need to do? Excited atoms are required to wait at this upper level or the upper lasing level till a large number of atoms accumulate over here. Why? Because N2 has to be greater than N1. So they should accumulate at that level. Therefore, an excited state with a longer lifetime is required. Such longer lived upper level from where an excited atom does not return to the lower level at once but remains excited for appropriate time are known as metastable states. So phosphors are examples of materials with metastable state. So basically what should happen? The atoms stay in the metastable state somewhere in the middle. This is suppose my E1, this is my E2, and this is my metastable state. So atoms stay in the metastable state for very fraction of a time, 10 to the power minus 6 to 10 to the power minus 3 second, that is microsecond to millisecond. So this is what? This is 10 to the power 3 to 10 to the power 6 times longer than time of stay of atom at excited level. So therefore it is possible for a large number of atoms to accumulate at a metastable level. The metastable state population can exceed population of lower level and it will lead to a state of population inversion. That is a must. So if there is no metastable state, means no population inversion, so no simulated emission and no laser operation. So this is as good as the heart of the lasing action. So the basic foundation of the laser action is the existence of metastable state. So you need to have a proper active medium and a metastable state for the laser action to take place properly. That's what is very, very critical. So now we'll move immediately to the next topic, which is pumping scheme. Last time we had defined what is pumping. Now we'll say pumping scheme. They are basically classified into three types. One is second level, then the third level pumping, and the fourth level pumping. This second level pumping is actually not of much importance because this will not lead to lasing action. But this 3 and 4 level is very, very popular, correct? But even though we need to study as far as what they mean by second level pumping scheme, what happens there, even though it will not lead because there is no metastable state. You need to go to higher, then only you expect the pumping scheme or the lasing action to take place properly. So we'll just define this, or we'll just check what happens in the two-level pumping scheme. So two-level pumping. So here what happens basically, most easy method to establish population inversion is to pump excess of atoms into higher energy state by applying intense radiation, but this scheme is not suitable for attaining population inversion. So as population inversion requires a built-up of population in the upper level, we need to have n2 greater than n1. It is possible only if upper level is populated faster than it decays. It will keep on going, more number of atoms, but will not stay there. It will come down immediately. So it is possible only if upper level is populated faster than it decays. So population of upper level exceeds that of the lower level. It is possible only if, what is the condition? Only if lifetime of spontaneous emission is longer. Therefore, it is required that the lifetime delta T at E2, this is my E2 energy level, E2 must be longer, correct? E2 has to be longer. So what we'll use the expression over here, we'll use the famous Heisenberg's uncertainty principle. So Heisenberg's uncertainty principle, what it says, the line width delta E2 of the level E2 and delta T, okay, are given by the expression delta E2 into delta T is greater than or equal to H cross. So delta T will be longer if delta E2 is smaller. This implies what? E2 must be narrow, but if E2 is narrow, one need specific frequency photon to pump atoms, but highly monogrammatic source required frequency is not easily available. Exactly, it's not possible. So also pumping radiation excites ground state atoms on one hand and induces transitions from upper level to lower level. So the pumping operation simultaneously populates and depopulates the upper level. It will keep coming but will remain for a shorter time and it will depopulate again, right? So population inversion cannot be achieved in the two-level pumping scheme. So the transition between the two levels that generate stimulated emission is called as the lasing transition. Very important word, lasing transition. So the terminal level is called as the lower lasing level and the upper level is called as the upper lasing level. The upper lasing level should be a metastable level and the uppermost level to which atoms are excited is known as the pumping level. The transition between ground level and pump level is basically called as the pump transition. So even though second level pumping scheme is not recommended for the lasing action because there is no population inversion takes place, but even though we need to know what must be happening by which it is not possible because here there is no metastable state, so we can't expect the lasing action to take place properly over here. Okay, so this is in short what happens as far as the two-level pumping is concerned. So in the next lecture we'll see to it that how the 3-level and the 4-level pumping helps the lasing taking place properly, and even out of these two, 3-level is very, very popular because here we can achieve a better metastable state, correct, and you get a very good response of the population inversion also. So that we will study in our next video lecture. So today we have defined very important part, which is active medium, then the metastable state, and as far as pumping is concerned, the 2-level pumping scheme, that this is not easy for us to achieve n2 greater than n1, but this is the condition for the population inversion. Okay, so we will move towards the 3 and 4 level pumping scheme in the next video lecture. Thank you very much.